Welcome to Fast Math Solution on Maths with EJD. In this video, we'll be talking about how to derive the formula for the sum of a geometric sequence. All right. So, given a geometric sequence, A, AR, AR squared, AR cube, and so on and so forth, up to AR n minus 1, where A is the first term, R is the common ratio, and n is the number of terms. N is the number of terms. Okay. Now this is the sequence itself. So to find, or rather to derive, right? To derive the sum of the sequence. Suppose that the sum Sn is actually A plus AR plus AR squared plus AR cubed, and that goes on until we get to AR raised to power n minus 1. All right. So if we have that, right, as the sum, I mean, this is the sum in literal terms. That's us adding everything together, but it's not realistic if we have several terms, right? If we suppose that and multiply multiply that sum by the common ratio, which is R, so that we now get R multiplied by Sn. So each term multiplied by R. So you have A times R, that would now be AR. So it shifts it, like you now have the next term. So you have AR plus, instead of AR now you have AR squared. Instead of AR squared up there, you have AR cubed. Instead of AR cubed, you have AR raised to power 4, and that keeps going until, instead of AR raised power n minus 1, you have AR raised power n. But of course, before AR raised power n minus 1, there should be AR raised power n minus 2. So that multiplied by R will now give you AR raised power n minus 1 before you finally have AR n minus 1 multiplied by R. That will be AR raised power n. Okay? So if we multiply this now, you see we have, this is now RSN. This is now what we can call RSN. Okay? Now, what if you now subtract, if we subtract RSN from Sn, then we are going to have Sn minus, we are going to have Sn minus RSN. So remember, Sn again is what? It's A plus AR plus AR squared plus AR raised to power 3 plus all this plus AR raised to power n minus 1. So all this now minus RSN. So AR plus AR squared plus AR cube plus AR raised to power 4 plus all that plus AR raised to power n minus 1 plus AR raised to power n. So we are subtracting this. Now imagine that, so you see, since we are subtracting 10 by 10, right? A doesn't no longer exist down here, but we have it up there. So A is going to remain. So AR cancels AR, because of this minus, AR squared cancels AR squared, AR cube cancels AR cube. There's going to be AR4 after AR cube. So this is going to cancel this. AR n minus 1 cancels AR raised by n minus 1. So you now have A and ARN left. So these are the two numbers you have now. So we can then say that is the same thing as Sn minus RSN equals A minus A raised to power Rn. Okay, so we can tidy things up here now by factorizing. So Sn into 1 minus r, right, equals a into 1 minus r raised to power n. So if we divide through by 1 minus r, so we have Sn into 1 minus r equals a into 1 minus rn divided by 1 minus r divided by 1 minus r. So this cancels out. So we have Sn equals a into 1 minus r raised to power n all over 1 minus r. Now, this is finally a very tidy formula for the sum instead of that long thing we had. But the issue with this is this. The issue here is that r cannot be equal to 1. If r is equal to 1, then this sum fails, right? This sum fails. So this formula only holds if r is not equal to 1. Now, what happens if r is 1? Because that's actually possible, right? So suppose that r is equal to 1 such that the geometric sequence is the constant sequence is the constant sequence. So constant sequence simply means that if the first term is A, the second term is A, the third term is A, and everything goes on until you get n A's like that, right? So you have n terms of A. So suppose that the R equals 1 such that the geometric sequence is the constant sequence A, all the way down. Okay. Then the sum can be expressed as Sn equals n multiplied by a, because you have a in n places, basically. Okay. Okay, so now we have the sums, right? Well, let's just summarize. In all, we have Sn equals a into 1 minus r raised by n all over 1 minus r, given that r is not equal to 1, and Sn is equal to n multiplied by a, given that r is equal to 1. Okay, so these are the two expressions for the sum to the nth term, sum of the first n terms of a geometric sequence. And that's how that's been. So expect more of these videos as for these solutions to problems. So you don't want to miss out on any of that. So you need to subscribe to this channel and hit the notification bell so that you can always uh get alerted each time a new video is released. So be sure to do that. For those who have subscribed, thank you very much. I'm grateful for that. If you need me to solve a problem or answer a question, or you just want to tell me how helpful this video is, please feel free to use the comment section and then like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.